everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम लोग जो क्लास करने वाले हैं वो IM की क्लास करने वाले हैं जो कि इंडस्ट्रियल मैनेजमेंट की क्लास है. एंड फर्स्ट ऑफ ऑल इट्स अ ह्यूज रिक्वेस्ट टू ऑल ऑफ यू, प्लीज़ गो थ्रू विद द सब्सक्राइब बटन अगर आप हमारे चैनल फर्स्ट टाइम देख रहे हो. इंडस्ट्रियल मैनेजमेंट की जो आज की क्लास है वो 10th क्लास है एंड दिस इज़ द लास्ट क्लास ऑफ इंडस्ट्रियल मैनेजमेंट, जिसमें हमने ऑलरेडी यूनिट 5 कंप्लीट कर देंगे. जिससे पहले इसकी पहले की अगर हम बात करते हैं तो हमने यूनिट 1, यूनिट 2, यूनिट 3 एंड यूनिट 4 कंप्लीट कर लिया है. नाउ हम लोग यूनिट 5 स्टार्ट करेंगे जो कि आपका प्रोजेक्ट मैनेजमेंट यूनिट का नाम है. आज ही क्लास स्टार्ट भी करेंगे, आज ही एंड अप भी कर देंगे. तो दिस इज़ योर यूनिट 5, दैट इज़ योर प्रोजेक्ट मैनेजमेंट हियर. दिस इज़ योर क्लास 10th. फर्स्ट ऑफ ऑल इट्स अ ह्यूज रिक्वेस्ट टू ऑल ऑफ यू, जो भी हमारा चैनल फर्स्ट टाइम देख रहा है, अभी तक हमने हमारा चैनल को सब्सक्राइब नहीं किया है, इट्स अ ह्यूज रिक्वेस्ट टू प्लीज़ गो थ्रू विद द सब्सक्राइब बटन so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Now we'll start with the project management. So first we have to know about some related points, that is your project here. In the terms of a project, if I'm talking about project here, the Project Management Institute, that is PMI USA, defined a project as a temporary endeavors undertaken to create a unique product or services. In the regard of it, the projects are the plans which are required to complete the complex and a special work. It requires an expert knowledge from the various departments. Even though the project team is created for a specific project with a high degree of the technical skills, the project manager is responsible for the success of a particular project. And with the project need a different kind of a management. The role of the management is to plan, organize, integrate resource and the task to achieve the project goal as well. As of project management, I had told you many definitions regarding it. The three definitions and the one is written here as well. Now we'll discuss about the characteristics of project. What were the characteristics of project that we have to deal with? In the characteristics, the important characteristics of the projects are as follows, like that. The first characteristic of project we have that involving a single definable purposes and well-defined and items of deliverables. The second is the unique, this is the characteristics of project. The third we have is a somewhat or largely unfamiliar. The fourth we have here in the reference toward the characteristics of the project, that what we have to deal with the reference to the project management here. Each and everything is very important when you are paying attention regarding the unit 1, you are preparing for an examination. The fourth we have is that is the utilizing the skills and the talents from the multiple professions and organization. The fifth characteristics of project is that a temporary activity, and the sixth characteristics of project is some thing at stake. And the seventh is characteristics of project we have is that the process of working to achieve a goal as well. Now we'll discuss about the project planning. That is, the project planning is a rational determinations of how to initiate the certain and sustain and terminate a project. And with reference towards it, we can say that the project planning is that process of thinking, making explicit the project's objectives, goals and strategies that is necessary to bring the project through the life cycles to a success determinations. When the project's product or the services take its rightful place in the executions of the project's owner strategies. In reference towards it, as I told you, that the project is a rational determinations to how to initiate, sustain and terminate the project. Even the project planning controls are integrated here. And in this type, the two important project planning and control tools we have is, the first we have is CPM. इसका फुल फॉर्म होता है क्रिटिकल पाथ मेथड. द सेकेंड इज द PERT. These were the two tools. So these were the tools. First is CPM and the second is PERT. CPM जो होता है वो होता है critical path method. I will just write it down so that you can write it down, that critical path method. And for the PERT one here, that is your program, evaluation and review technique. So that is the program, that is a program, evaluations and review technique here. Now we'll discuss about the different types of events, and before that we have to know about the representations of different types of a project network. that there are the events used to represent the start of the completions of an activity, and that circles are used to represent the event as well. The circles are also known as the nodes or the connector that we are drawing here. The existing three types of events we have is the merge event, burst event, and a margin burst event here. In the reference towards the merge event, what it is that one or more activities join to an event. These events are known as a merge event. Like example, that is, this is the nodes or connectors here. These were the event that is joining here, two or more than two. Okay, so these were the events. This is known as merge event here. Now we're talking about the burst event, when one or more two activities leave out an event, and these events are known as burst event. For example, this is a node. This is arrow is towards outside because it is going out. This is inside, that is coming to an end. Okay, this is the representation of burst event here. And now we'll talk about the merge and burst event here. In the reference towards it here, that is, this is the activity where the merge and the burst event exists, and in the reference towards it we have it this is the burst event that is gone towards it out. This is coming to end. So this is what we can say, that is merge and burst event here, that this is an activity where merge and burst event exist here. Now we'll talk about it. So here we'll talk about the network models here. In the terms of the network models, gone through with the network models here. In the terms of the network models are used for finding most efficient way of linking multiple locations by the shortest route, and also network models are applied for, like, first is to determining the maximum flow in the pipeline network. The second is to determining the minimum cost flow that satisfies the supplies and the demand at a different location. The third we have is the scheduling the activities of a project as well. In the case where the some non-traditional applications of network models are, the first is to determine the optimal equipment replacement policy, that is the shortest route model, and the second is to transportation schedule, that is the maximum flow model as well. Now we'll talk about the terminologies in the network models here. In the terminologies, that a network comprises of a set of nodes, that the nodes are interlinked by the arcs or branches. A network is denoted by the a comma, that is your n comma a, n comma a here. In the reference towards it, where n is a set of nodes and a is a set of arcs, that is the branches here. For example, the network that we can draw here. This will interact to one another. So this is a sort of linking which makes a network model here, as you can see here. Okay, this is a representation. See, this is from one node to second node, the third node, then it fourth node, and then of course this is the fourth node, this is fifth node, and this is sixth node. This is the to one to another. One up is connected, and second up a third connected, fifth connected, and then of course after that the third one is connected to sixth here, third one is connected to fifth here, third one is connected to fourth as well, the fourth is connected to two here. So all are interconnected here. That is the examples of any network that has been represented. That is, we can see that the network models here. Now we'll go ahead with moreover and more further that to discuss about the network models in reference towards it, where we can say that that n is equals to 1, that is your 1 comma 2 comma 3 comma 4 comma and 5 comma here, and because they are connected to one, more than 2, and 6 is not connected to more than 2, that's what we can write it down. I just write it down here. N is equals to 1 comma 2 comma 3 comma 4 comma 5, and a is equals to 1 comma 2 1 comma 4 2 comma 3 2 comma 5 3 comma 4 3 comma 5 and 4 comma 2. So this is a flow of associated with each network, that the flow is decided to the capacity of its arc, where we can represent as that is 2, and that is connected to this is 4 and this is 5. This is the tree network, and an arc is detected or estimated when its arrows, that positive flows and in one directions, and a network is called a directed network, and when all the arcs are directed here. In the request of this, that the sequence of the distinct arcs that joins different nodes that form a path, and a path can form a loop or a cycle. For example, like 2 comma 3, that you can see here, that for the case of the 2 comma 3 here, and for the 3 comma 4 as well, and for that another one that we the 4 comma 2 here. So this was making a cycle here, and that is an cycle of free connected network that is consists of the subset of all the nodes, and that are known as tree as well, and with Z represented here, and a tree that links all the nodes of a network is called a spanning tree, and that we can say that 1 is connected to 4, and then 4 is connected to 2, if you can go through with 2 with connected to 5, and 5 is connected to 3, and 3 is connected to 6. So this is forming a spanning tree here in the reference towards it. Now we'll go ahead with another one, and that what we have to discuss is a critical path method, that is known as CPM, as I told you about it. In the critical path method, that is CPM, that CPM is applicable to both small and as well as large projects. CPM is a technique used for planning and controlling the logical sequence of operation for accomplishing a project here. In the recover of that, the CPM planning technique involves breaking project down into the various activities and determining the required length of time for each activity as well. Now we'll discuss about the CPM planning steps. So the CPM planning techniques involve the following steps. The first is to specify all activities in the projects clearly. The second is to arrange activities in a logical sequence. The third is an arrow diagram reflecting the sequence or relationships must be developed. Events and activities are numbered. And the fourth is to calculate the time for each activity, marked activity time, and arrow diagram that estimate the early and the late start and finish times as well. The fifth is to calculate the total float for each activity, and the sixth is to mark the critical path on the diagram, and the seventh we have is to estimate a project completion time as well. Now we'll discuss ahead with another one, and that is an activity that is referred as critical when there is no loss of time in determining its start and finish times as well. When there is a slight advancement or the delay of the activities without affecting the completion date of the entire project, it is referred to as non-critical activities as well. A node that is termed as an event where one activity is finished and the next activity is started for an event J, that is different occurrence times are specified as. So that has been represented if I'm talking about for the this of J, that is represented earliest occurrence time, and this is of triangular of J, that is represented the latest occurrence time, and of course that DI of J, that is represented the durations of activity here. In the regard of it critical that as I told you, critical path or method about it, and about the critical path that is your steps here that we had discussed about it. So here moreover when we are going to in deep, and that what we have to discuss about it in the reference towards the CPM, that if the process start at node 1 and advances recursively to end at an n, and that it is called as the earliest occurrence time, that is of as I told you about the science, that is earliest occurrence time, or you can say that the forward pass as well. If the process starts at a node and that it ends from the one at a node 1, and that it is called as the backward pass or the latest occurrence time, that is represented by this. And then after that, the completions of the earliest occurrence time, that is there are the two steps that set that is of rectangle j of equals to 0, that is as project starts at time 0. And notice you can nodes p and q and till the v that are connected to node j, that is incoming activities of p of j, of p of j, and of v of j, that is where the longest part durations of the node that has been represented here. So we'll add an all and then we'll find it out here. For the reference towards it, the computations of the latest that occurrence time, where that is of delta of n equals to, that is the square of n here, in reference towards that, since the earliest and the latest occurrence of the last node of the project are same. The latest occurrence time of the node j that's given here, and an activity I of j is a critical which satisfies the following conditions, that delta of I is equals to, that is this is of I, that delta this triangle of j is equals to that's j, and that is j of I minus that all is equals to d of ij. In the rare cases that the constructions of the time schedule for an activity of I comma j, the delta of I, that is this is a rectangle of I is representing the earliest start time, and delta of j, that is representing the last completion time as well. And here at that we can say that the constructions of the preliminary schedule here, a preliminary time schedule for different activities of the project is drawn, and the critical activities are shown by the solid lines one after the other, and ensuring that the projects should be completed in the specialist duration as well. The non-critical activities are shown by the dotted lines, and that non-critical activities spans larger durations in the allotted time intervals as well. And normally it preferred to start with the non-critical activities, and that has been represented. In the second one, we have your first is your constructions of preliminary schedule, and the second we have is your that I had about tell you about. And the second we have is that has been done in the project and the time schedule. The second we have determinations of loads here. In the determinations of loads, that the slack time available within the slotted span of non-critical activity, that is called as float. And the two types of the float are commonly defined as, the first we have is your total float, and the second we have is your free float. In the case of the total flow, that is defined as the excess time that span from the earliest occurrence of an event I and to the latest occurrence of event j for an activity of I comma j, that total float is being expressed as tf I of j. And that is where free float is defined as an excess of time that is a span from the earliest occurrence in the events of I, and that is to the earliest occurrence of event j, and over the durations of I comma j, that free float is expressed here. So that is represented by double F here, capital F, and where the relationship between the free float and the total float is that free float I of j is less than or equals to total float of I of j, that is the representation. Now we'll talk about the third one, that is the red flagging rule here. In the red flagging rule, for the non-critical activity I comma j, that free flag in the case of the free flow, that is equals to the total flow, where then an activity can be scheduled anywhere within the span and without conflicting schedule. And when free flow is less than total flow, then the start of the activity can be delayed by the free flow from that start time and without conflicting the schedule as well. Now we'll discuss the moreover about it, and that's what we have to discuss here. And as you can see here, we'll discuss another topic, and that is your PERT here, and that that is also an important one here. In the regard of it, PERT, that what we have to go on through with Nadeep, that is the PERT planning method involves the breaking projects down into the activities and determining the required length of the time for each activity here. In the reference towards it, that the PERT is a network technique for a planning on monitoring and control of the large projects. That PERT is commonly employed for the conducting the initial review of the project. Even though PERT anticipates the potential areas of the problem which may disrupt a program objectives, because of this timely action can be taken to prevent the occurrence as well. In the regard of it, the PERT planning steps what we are following here. In the PERT planning steps, if I'm talking about the PERT planning techniques, involves the following steps, that is to specify all activities in this project clearly. The second is to arrange the activities in the logical sequence. The third is to a network diagram reflecting the sequence relationship must be developed. Events and activities are numbered. The fourth is to using the 3 times estimate for each activity must be calculated to mark on the network. And the fifth is the standard deviations of the variances for each activity are computed and recorded as well. The sixth is the network must be evaluated by calculating the critical path, and the critical path is marked on the network diagram. These various activities can be then scheduled. And the seventh is the length of the critical path is found out, and the eighth is that finally the project completions can be estimated. Now we discuss about the time estimates here. In the time estimates, the various time estimates calculated in the PERT techniques are, and they are the four here. That is, the first is the optimistic time, that is here, that is represented by TO of O. The second is the most likely time, that is a pessimistic time, and then expected and average time here. In the regard of it each, we have to discuss one by one. For the optimistic time here, that it is the shortest that is shortest possible time in which an activity can be completed if everything is favorable. The second is the most likely time, that is comes under that it is the time when an activity will take it is at the time in which the activity normally expected to complete under the normal contingencies. The third is the pessimistic time here, that is, it is the time which an activity will be to complete in case of the difficulty, that is, if the mostly of the things go wrong. It is the longest time along that all the three times here. The next is your expected or the average time, and that is here, that is the expected time for each activity that can be calculated. I just write it on the formula that you have to do in all each and every question here. T of E is equals to T of plus 4Tm plus T, and upon 6 here. This is the formula that you have to use to find out in each of the questions here, in each of the following questions. Now we'll go ahead with the deep here. Now we'll discuss about the difference between the PERT and the CPM that we have to discuss, and that is also an important one here. Now we'll discuss about the difference between as of PERT and CPM. That is all are important reference towards it, as I discussed here. So this is the difference between the PERT and CPM. Now we'll discuss one by one the differences. This is the PERT and this is related to CPM here. In the PERT, the first difference is that the PERT is a probabilistic model of the project planning, and in the CPM is a deterministic model of the project planning. This is a probabilistic model and this is a deterministic model of the project planning here. In the PERT here, that is expected project completions time in the determined by TO, TM and TP, and in the CPM, that expected project completion time is actually time taken. The third difference we have is that PERT is an event oriented approach, and in the case if I'm talking about the CPM is an activity oriented approach here. In the fourth one, if I'm talking about here, the fourth is that a network diagram is drawn for PERT here, and for the CPM an error CPM diagram is drawn for CPM here. Let's go ahead with the fifth differences here, that is sometimes dummy activities are used to represent the proper sequencing, and for the CPM, that is dummy activities are not required in the CPM here. Let's go ahead with another one, and that is the sixth differences between the PERT and the CPM here, and that what we have here is the sixth is the critical and non-critical activities are not differentiated. In the PERT, that CPM, that is the critical activities are defined closely. The seventh difference between this, that PERT is suitable for a large project, and for the CPM is suitable for a large as well as a small project here. For the PERT here, that resources are not utilized effectively, and for the CPM here, that is the better utilization of resource as well. Let's go ahead with another one, and that what we have to discuss here in reference towards it, that is the probability of completing the project within the given time. In the reference towards it, if I'm talking about the probability of completing the project within the given time here, in reference towards it, that by using the probability of the distributions, the probability of completing the project by the scheduled time is given as like that is z is less than or equals to, that is of t of s minus t of e upon, that is sigma e here, where that we can say that the z is equals to ts minus te upon sigma e, and that is where this ts is known as your schedule time. I can write it on schedule time, and this is t is expected completion time of project, and this is the sigma e is the variance allowances, the critical path here. In the reference towards it, that pz less than equals to, that is ts minus te sigma e, and that is equals to x upon 100, where this x that gives a percentage chance of the product being completed, and the value of x by 10 is obtained from the normal distribution table here. Now we'll discuss about the components involved in a project here, a project that of cost analysis, that the components involved in the project cost analysis. Logical sequence of projects activities give the probability of completing the project. Here the cost of the resource consumed by the activities are not considered. So first we have is your budget, the second is your direct cost, the third is indirect cost, the fourth is the normal cost, and fifth is a crash cost here. Now we'll talk about one by one in each. In the reference towards the budget cost here, the budget, it is the projected cost of the project. This cost include direct cost and indirect cost as well. In the reference towards the direct cost here, the direct cost, it includes the manpower, material, overheads related to the project as well. In the third indirect cost, the indirect cost, it includes the salaries of office personnel and office rent, interest on loans, etc. The normal cost here, that is, it is the cost of the incurrent in the normal course of project with the considerations of optimal utilizations of resource in completing the project here. Now we'll talk about the crash cost here. The crash cost is that the crashing is a process of reducing activity time to minimum with increase in the cost of project. The time is reduced by the reducing activity time by using the extra resources, materials and manpower here as well. Let's go ahead with another one, and that what we have to discuss about the project crashing here. Now we'll go ahead in deep in reference towards the project crashing, and then after that we'll discuss the procedures of for the project crashing here. In the terms of the project crashing here, that the project crashing is used to reduce the project completion time by employing the extra resources. The total budget of the project increased significantly with the reduction in completion time here. In the regard of it, we can say that the procedures for the project crashing here, the first steps involved in the project crashing is first is that to determine the normal project duration associated with the critical path total cost. The second is to compute the closed slope, where the cost slope is equals to the crash cost minus normal cost, and upon normal cost minus crash time, then we can find out the cost slope. I can just write it down here. Cost slope equals to crash cost minus normal cost upon normal time minus crash time. This is the formula to find out the cost slope here. To add the third procedure step we have is that identify an activity for crashing which has the lowest cost slope value, then a crash, then activity to the lowest possible time, and find total cost as well. We will with the formula of the total cost equals to, that is the direct cost plus the indirect cost that you can add in on, and you will get the total cost here. The fourth procedure point we have is that find the critical activity and the critical path of resulting the networks of step 3 and complete the new project duration, the cost total cost here. Then after that we have a fifth point, that repeat step 1, 2, 3 and 4 till all the activities in the NW that get crash at the lowest time, compute new project durations, and of course the total cost as well. Let's go ahead with the question here, that what we have to solve it out. Given the following data, compute the expected project duration that by drawing a network and indicate the critical path and find the total slack of the to each event. This is an activity here that is given. This is T naught, TM and TP. The activities has been given us that 1 say 2, 1 5, 2 3 and 2 say 4, 3 5 and 4 say 5 and 6 say 7 and 5 say 8 and 7 say 8. This is of T naught and then TM, and then of course we have to find out the TP that has been given in the table. So I just write it down for all this, and that what we have is 2 2 5 1 5 2 3 2 7. Then for the TM here, that is 5, then again 5 11 4 11 5 9 2 13 14 8 29 7 17 14 27 8 13. So here for the expected duration for each activity that is computed here, we'll just write it on the formula, and then after that we'll solve it out. So here this is what we have to apply, that is your TE equals to TO plus 4TM plus TP upon 6 here. So we'll find it out for the earlier time, that is, or we are going to find it out, that is T of EIJ, that is equals to max TEI plus T of IJ here. And for the least time here, that is T LJ, that is equals to min, and that is T LI minus T IJ. And for TE5, max TE4 plus T4 5 TE3 plus T3 minus 5. Then after that, what we have to find it out is the next one, that is the max. We put the value 10 plus 6, 19 plus 11, and then we'll find it out the value here, that is your max 16 comma 30 equals to 30 here. Next we'll find it out for the TL2, that is equals to min TL4 minus T2 comma 4 TL3 minus T2 comma 3. We'll put the value min 24 minus 4, 19 minus 13. So what we'll find it out the value, that is the min 20 comma 6, and that is equals to 6 as well. Let's find it out the value of the table, that what we have to find it out, and let's go ahead with the detail here that has been shown here. And let's go ahead, and this is the sequence, this is the table that has been shown here, that is the activity here. This is of T naught, TM, TP, T of E, that is of T of IJ, and then we have here that EST, LFT, and then LFT, LST, LFTD, and then of course total slack LST, E and EST. Here the sequence of activity is 1 comma 1 2 1 6 2 3 2 dash 4 3 dash 5 4 5 4 dash 5 6 dash 5 6 dash 7, and then 5 dash 8, and then 7 dash 8 here. Let's go ahead with the table here, that is the 2 that has been given in the question as well, so we'll just write it down here. 5, then 2, then 3, then 2, and then of course 7. For the TM that has also been given, so we'll write it down 5 5 11 4 11 5 9 2 13. For the TP that has also been given, we'll just write it down 14 8 29 7 17 14 27 8 13. Then for the TP, that as I told you about the formula, that what we have to find it out, that is 6 5 13, then 4 11, then 6 11 3 12. For EST here, that is for this we have a 0, then 6 6, then 19, 10, 5, 30, 16. For the next one we have to find it out, that is 6, 10, 19, 24, 30, 30, 21, 33, and 33 of course. Then we have here 0, 5, 6, 20, 19, 24, 10. Then after that we have a 30, then 21. Then we have 0, 5, 0, 14, 0, 14, then 5, then 0, and then of course 15 here. So here we'll draw a network diagram for this, and that what we have here. In the case of the network diagram, first we'll draw a pattern, that is 1, 2, then we have 3, 4, sorry, this is 3 and this is 5, then after that 6 is 8, this is 4, then we have here this is 6, and then we have here is 7. So we'll from the TE, that is TE is equals to 0, TL equals to 0 here. So here with regard of it, we'll go ahead, this is 6, for the TE equals to 6 and TL equals to 6 as well. Then we'll go ahead with the detail, and that what we have is the 13, and for that we have here that is 4 here, that is TE equals to 10 and TL equals to 24, and for that sake, yeah, we have here is your 6. And then after that, this is a network diagram, that what we have to solve it out and what we have to form it out, and that is T equals to 19 and TL equals to 19, and here that is T equals to 30 and TL equals to as well 30. Then after that we'll go ahead, that is 3 here. So here TE equals to 33 and TL equals to 33 as well, and here this will go on towards it, and this is 12 here, and here that is TE equals to 16 and TL equals to 21, and for that sake 11. So here TE equals to 5 and TL equals to 10. Let's go ahead here, this is 5. So with regard of it, I will be solving out, this is a network diagram that has to be formed here. So in the reference towards it, we'll go ahead with another one, and that what we will solve with a question here as well, the another question that what we have to solve it out. Let's go ahead with the question here. As you can see that the following table lists the jobs of network that along with the time as well. Here are given, that is the jobs and the durations in the days as well, that has been represented here. And here for that this is the optimistic to mostly likely TM, and that is the permissive TP here that has been given. In the reference towards it, if I'm talking about with the help of the Venn this the diagram, the network diagram, so the critical path I will just make you write. Here we'll go ahead with the critical path, and that what we have is 1, 2, 3, 5, and then of course 8 here. Then expected project duration is of course that is expected project duration we have is 33 days here. And for the start time for each event, that is TL minus TE, so we'll go ahead for event 1 here, and for that we have that is TL minus TE, so we'll have 0 minus 0, that is equals to 0. for the event 2 we have 6 minus 6, that is equals to 0. Then for the event 3, that is 19 minus 19, that is equals to 0. And of course for TL event 4, that is 24 minus 10, that is equals to 14 here. Then of course we have event 5, and that is your 30 minus 30, that is equals to 0. Event 6 is 10 comma 5, that is 10 minus 5, that is 5 here. Event 7 is 21 minus 16, that is your 5. And event 8 is, that is 33 minus 33, that is equals to 0 here. So with regard of it, a following table list of the jobs, as I told you about the following tables are jobs, that is time estimated here, that is job durations in the days, and optimistic too, mostly likely, that is TM, and pessimistic as well. In the regard of it, we have a sort of a table here, and that we have to continue here, and that is your the jobs is to 1 4 1 to 3 1 to 2 to 4 to 5 3 to 5 3 to 6 and 5 to 6 and 2 to 6 as well. In the regard of it, each we have to fill it out. 3 6 1 3 2 6 4, and for the mostly likely to, we'll have to find it out, that is for 9 6 12, then 4 9 5 12 and 19. Then for the next one we have here is, that is 27 15 30 7 27 8 30 28. So this is a formation of table. Now we'll go ahead with the another one. So here the first we have is that you have to draw the project here, project network, and the second is what is approximate probability that jobs on the critical path that will be completed by the due date of 35 days. And the third is we have is what is your estimate of probability that the entire project will be completed by the due date. And the fourth one is that what due date has 90% of the chance of being not. So in the case of it, first we will be having to draw a diet table here, and then after that, so first for that sake we will be drawing here the sake of like critical table, and for that sake we will be drawing here, and for that we have to first complete all this. So here we'll go ahead and we'll form a table here. So that is the first one, we have an activity, then we have T naught, then TM, then TP, and then of course we have TE, that is equals to TO plus 4TM plus TP upon 6, and here we'll have sigma E square equals to that is of TP minus T naught upon 6, and that is a whole square as well. For the activity here we will go ahead now. We'll find it out for this, that is your 1 comma 4 1 4 1 3, then 1 2 here, and then of course 4 5. So for that for 1 comma 1 4, that is the TO is 3, the TM is 9 27. When put the value, we'll get the answer 11 here, and after that 24 upon 6, that is a square, and 6 ones are 6 6 fours are 24, and 4 fours are 16, so the answer would be 16. For the 1 comma 3 we have here, that is 3, it is a 6, this is 15, then we have 7 here, and we'll do that, that's 12 upon a 6 whole square. 6 ones are 6 6 twos are 12, and 2 twos are that is your 4 here. For 1 comma 2 here, that is your 6 here, 12, and this is 13, and this is of course 14. For that sake, that is your 24 upon 6 whole square, that is your A here also, that is the 16 here. For 4 is the 16 here. 4 comma 5 we'll do in another one here. So this is for 4 comma 5, this is 1 4 7 4, and then 6 by 6, that square is 1. Then we have is your 3 by 5 3 comma 5, this is 3, this is 9 27, this is 11, and then we have your 24 upon 6, and that is square. 6 1 is 6, 6 4 is 24, and that is 4 4 is 16 here, that is 1 here. Yeah, this is a 16 here. Let's go ahead for the another one, that is your 3 comma 6. This is a 2 here, and this is for 5, this is 8, and then we'll get here, this is your 5. So here for 6 by 6, that's the whole square is 1, and that is 1 square is 1 here. For the one next is your 5 comma 6, and that is your 6, and then we have 12, then we have 30, this is 14, and this is your 24 comma upon 6, the whole square is equals to, that is your 16 here. Let's go ahead with another one, that is your 2 comma 6, that we have is your 4, and then we have here is 19, and this is your, of course, this is your 28, and then this is your 18 here. And after that, for this we can say that the answer would be the 24 upon 6 the whole square, and that is equals to 16 here. Let's go ahead with another one, and then what we have to find it out for the critical path, that is we have to find it out. And for the critical path, we have the paths here, and of course the duration. For the path, we have is 1 comma 2 comma 6, 1 comma 3 comma that is 6. So this is for this, that 14 plus 18, that is equals to 32, and for 1 3 and 6 here, that is 7 plus 5, that is equals to 12 here. Let's go ahead with another one, and that what we have is another critical path is 1 3 5 6, and for here, that is the 7 plus 11 plus 14 equals to 32. For the another one, we have first plus 1 4 5 6, and for here that we have is 11 plus 4 plus 14, that is equals to 29. So this is a critical paths and as well as the durations here. For that sake, we will having a different durations, and then we will go on ahead. And now we'll have therefore the critical paths, what we'll get here is the critical path is 1 2 and 6, and 1 3 5 and 6 here. For the network diagram, we will be finding out for the network diagram here, and that what we have to draw here is your, that is 1, then we have 3, and then of course we have 6, then we have 5, here we 4, and of course here this is 2. For this we have here, that is a 14, 18, this goes towards it, so it will be forming it 14, this is 4, this is 11, this is 7, this is 5, this is as well as 11 here. So these were the network diagram that has been done. This is now we'll find out the approximate probability. In the case of the approximate probability here, for the expected project completion time would be 32 days, and for that critical path, and this is a variance. For the critical path, if I'm talking about here, that is 1 comma 2 comma 6, and this is 1 3 and 5 and 6. For 1 2 3 6, we have a 16 plus 16 equals to 32, and for this, that is 4 plus 16 plus 16, that is equals to 36. Considering the path with the largest variances, that is the 1 3 5 and 6, this one, and with regard of its standard deviation for the critical path of this, that is the answer would be the 36. So we'll be finding out under root 36, and we'll get 6 here as answer. Now for the probability of the completion of project is given by the probability that, as I told you about, like z is less than equals to t of s minus t of e upon a sigma of e here, and where the ts is the proposed completion time, that is the ts is equals to 35 days, and the te, that is the expected completion time, is 32 days here. And now for the probability we'll be finding out, and for that, after that, the third part that they had asked you about it, what we'll have to find it out. And for that sake, the probability is z is less than equals to 35 minus 32 upon sigma, and that is equals to the probability z is less than equals to 0.5. But for the third point that I had told you about to find it out, that but using the normal distribution table where z is equals to 0.5, what we had find it out here, and that is for that the completions of the project within the 35 days is like 1 minus 0.1915, that is equals to 0.8085, and that is equals to 80.85% here. The probability that the projects can be completed in the 35 days is 80.85% here. And for the fourth part, that is for 90% chances. And then for that, completions of the project with the x days is like 1 minus 0.9, that is equals to 0.1 here. And for that sake, normal distribution table for the 0.9, the value is that is z is equals to 0.26. So for now we will find it out the value, that is x minus 32 upon 6, and we'll put the value, that is 0.26 is equals to x minus 32 upon 6 here, and that is equals to x is equals to 33.56 days. This will be the answer here. Now we'll find it out the another one, that is the another question here, and that for that sake we have here. So the question we have is that the activities involved in a small project that are given into and they construct a network and find out the critical path, find find out the float for each activity. The activity has been given, that is 1 2 and 1 3 2 3 2 4 and 3 5 and 4 5 as well. The duration says for the 1 2 we have is 20, 1 3 के लिए 25, 2 3 के लिए 10, 2 4 के लिए 12, 3 4 के लिए 6, and of course the 4 5 के लिए, that is 10 here. For the activity network, if I'm drawing the activity network diagram here, that is the activity network diagram, in that case what we have to do it in that case we have to draw a diagram, and this is a 1, this is 2, this is 4, this is 3, and of course this is 5 here. So for that sake we will have it, this is 20, 25, 10, 12, 10, 6. For that case, this is a network diagram that has to be you have to made it out, and that is also an important one with regard of it. And with respect towards it, if I'm going through it, so the critical path we have here, for that sake the critical path we have is 1 2 3 4 5. So for that sake the project time, we can say that the project time is equals to 20 plus 10 plus 6 plus 10, and that is equals to 46 days here. And for the earliest shortest time, the earliest possible time at which an activity, an event can occur or start after completing all these preceding activities. So for the earliest first time here, you can see here, as I've told you, that earliest start time, that is the earliest possible time at which an activity, an event can occur or start after completing all its preceding activities. And earlier finish time here, that the earliest possible time by which an activity is finished here. The latest start time here, that is the latest time of an event I that can start without affecting the total project completion time. And the latest finish time here, that is the latest time that which an activity is completed without affecting the total project completion time here. Regard of it, the float here, and that is the float is also being divided into two. The first we have here, that is the total of float, and that is another one is your free float, as I had discussed about when we are discussing about the float here. So with the total float here, that is that is the latest start time, earliest start time, and for the free float, that is your latest finish time and the earliest finish time here. So here this is activities, this is the normal time, earliest time is the start time and the finish time, latest time is that start time and a finish time, and a float is the total and the free float here. Now we'll go ahead, that is the activities we have been given is 1 2 1 3 2 3 2 4 3 4 and 4 5 here. Now we'll put the value here. This is the normal time is 20 and 25, this is a 10, this is a 12, this is a 6, and this is 10 here. For the earliest start time for this we have a 0 and the finish time is 20. For this is the 0, this is 25, this is 20, and this is 30, this is 20, and this is 32, this is 30, and this is 36, and this is 36, and this is 42. For the latest time start time we have a 0 and that finish time is 20. Latest start time is 5, then 30, 20, and then 30, and then of course we have 23, 35, then we have here 30, 35, 36, and 46 as well. For the total float we have is 0, this is 3, also 0, this is 5, this is 5, 0, 0, this is 3, this is 3, 0, 0, and we have 0, and this is 4 here. For this now we'll discuss about the possible 2 marks questions here, and that what we have here. For that case we have steps involved in the CPM project planning here. At the steps in the CPM project planning we have, the first step is to specify the individual activities. The second steps that is involved is determine the sequence and interrelationship of those activities. The third is draw a network diagram. The fourth step we have to estimate the completions time for each activity. The fifth is to identify the critical path, that is the longest path through the network here. And then the fifth we have I had told you about the identify the critical path, and the fifth is to update the CPM diagram as the project progression as well. Now they can ask you about what are the benefits of the CPM, and in regard of it the CPM provides the following benefit. Here are the 4 following benefits are: the first is to provide a graphical view of the project, the second is to depict the interrelationship among the various tasks and activities, the third is to predict the time required to complete the project, and the fourth is to show which activities are critical to maintaining the schedule and which are not. In the regard of it, the next they can ask you define briefly PERT here. As after I told you about the PERT, that the PERT is the full form of PERT is the program evaluation and the review technique. In the program evaluation and the review technique, that is the PERT, is a network model that allows for the randomness in activity completion time. The PERT uses the 3 times estimate: optimistic, pessimistic, and most likely, which helps in establishing the probability of completing a project within a specified time and take the calculated risk before the commencing a project as well. It has the potential to reduce both the time and the cost required to complete a project as well. Now we'll discuss about the different steps involved in the PERT planning, and with regard of it, the PERT planning involves the following steps. That the first is to identify the specific activities and milestones. The second is to determine the interdependencies and the proper sequences of activities. The third steps is to construct a network diagram, and then we have another one that is the fourth step, to estimate the time, and that 3 time estimates if the probabilities are to be computed that is required for each activity. The fifth is to determine the critical path, and the sixth is to update the PERT chart as the project progresses here. Now we'll discuss about the benefits of PERT here. That is, the PERT is a useful because it provides the following information. The first is to expected project completion time. The second is the probability of the completion before a specified date. The third is the critical path activities that directly impact the completion time. The fourth is that the activities that has a slack time and that has lend resources to the critical path activities. And the fifth we have is the critical start and the end dates as well. Now we'll discuss how performances monitoring and project management is useful, list the benefits as well. In the regard of it, that once the project is completed, the performance review should be done periodically to compare the actual performances with the project performances. A feedback devices is useful for the several ways. It throws a light on and how realistic were the assumptions underlying the project. The second is to it provides a documented log of experiences that is highly valuable in future and decision making. The third is it suggests the corrective action to be taken in the light of the actual performance. The D is that it helps in uncovering the judgmental biases, and the E is that it includes the desired cautions among the project sponsors as well. In the regard of it, what is the slack time and the critical path of the CPM, that what we have to discuss here in the deep. The slack time in the critical path in the CPM is that the slack to the amount of the time that has an activity that can be delayed apart at earliest start on the earliest finish without the delaying the project. This is it comes under the slack time here. And with regard of it, the slack time for an activity is the time between the earliest and the latest start time on or between the earliest and the latest finish time as well. Now we'll discuss some of the MCQs that are very important. That MCQs with I will be providing you the answer as well. You have to go through with. But before my answer, listening my answer, you will have to answer by yourself that are you able to answer all of these questions or not. The first MCQ question we have here: the artificial activity which indicate then an activity following it cannot be started unless the preceding activity is complete is known as. For the options we have is that is the free float, event, dummy, and a constant. In the reference towards it, if I'm talking about, you have to answer it out. You can just answer it out, and after that I will be answering this question, and for that sake the answer would be your dummy. Let's go ahead with another MCQ question, the second MCQ question that we have here. So here I'll go ahead with another one, that is the another question here, that is pick up this correct statement from the following. The option A we have here is that the activity which consumes maximum time is called a node. The second is the activity is in the time consuming part of a project, and the C1 is that the beginning and end of a job are called events, and the D is that the logically and the sequentially connected activities are the events form a network. In the regard of it, if I'm talking about here, so with reference to this particular question, the answer you have to answer, and for my sake that the answer will be the option D, and that is logically and sequentially connected activities and the events of our network here. The next question, the third question of the session we have here is that the time by which the activity, the completion time can be delayed without affecting the start of succeeding the activities is known as. The options we have is that the inferring float, total float, durations, and the free flow. In free float here, in the regard of it, here we can say that the answer would be, you have to answer, and the answer would be the interfering float here in the regard of it. So here we'll go ahead for that sake for this particular question. No, this is not logically, this will the answer would be the option A here, and that will be the activity that which consumes the maximum time. It's called a node. That is the right answer. Not this will be the right answer. And for that the another one, and that here we notice A option is not right answer. The answer will be the D option here. That will be the right answer here. That is a free float. Let's go ahead with another one, and that what we have is that an important assumptions in the PERT calculation is. What you have to answer is, the options we have is the activity times are normally distributed, the B is the activity times are dependent, the C is A and B, and the D is A and C here. In the regard of it, we'll go ahead with option B, and that will have activity times are independent. Let's go ahead with another one, and that what we have here is another question. Which of the following is one of the assumptions of PERT here? आपको बताना इनमें से कौन सा ऐसा है जो कि assumption है आपका PERT का. For that sake, the option we have A is that the total project completion time follows a normal probability distribution. The second we have here is that the activity time are dependent and correlated. The C is that the project completions time follows a skew a square distribution, and the D is that the activity times are known with the certainty. In the regard of it, we will go ahead with the question, and for that sake we will have an option that will be the option A will be the right answer for this question here. In the regard of particular question, that what we have to answer it, and that will be your answer would be your option A will be the right answer. That is the total project completion time follows a normal probability distribution here. Let's go ahead with another one, and that what we have is that in a PERT network, the earliest activity start time is that options we have is that the earliest time that an activity can be finished without delaying the entire project. The second is that the latest time that our activity can be started without delaying the entire project. The third is the earliest time that an activity can start without violations of the procedures requirement. And the fourth is that the latest time that an activity can be finished without delaying the entire project. In the regard of it, what we have to answer it out, and for that sake we will have an option C will be the right answer for this question. And that is in the case that the earliest time that an activity can start without violations of the procedures requirement here. Let's go ahead with another one, and that is which is or are feature of PERT or CPM here. The options here we have is that option A is that an estimate of how long a project will take. The B options we have is that a graphical display of the project activities. The third is that an indications of the critical activities, and the D is that all of the above here. In the regard of it, we'll go ahead with option D, and that is all of the above, where an estimate of how long a project will take and a grouped display of the project activities and indications of the critical activities as well. These all three are right, and that will go ahead with the all the above here. Let's go ahead with another question, and that what we have to answer it, and that is another question here. In the regard of it we'll talk about like PERT and the CPM differs in that what we have a question, another question. The option A is that PERT uses dummy activities and the CPM does not. The second option, B option, is that PERT uses the three time estimates and the CPM uses single time estimate. The C option is PERT does not allow use to monitor cost, and where CPM does. The D option is that the PERT uses the AOA network and the CPM uses AON network here. In the regard of it, we'll go ahead with option B, and for that sake we'll have an option B. A right answer, that is PERT uses three times estimate and the CPM uses a single time estimate. The next question for that we have is that in PERT slack time equals to, आपको बताना slack time equals to किस में होता है PERT में. पहला ऑप्शन है EST plus T, LST, that is EST, then 0, or EFT or EST. In the regard of it, we'll go ahead with option B, and that will be your LST and EST. So we'll end up with this class, and with this industrial management today's we'll end up with this. And first of all, it's a huge request to all of you, please go through with the subscribe button, and you like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the regard of it, if I'm talking about the unit wise what we had cover up here, in that case that we had cover up the unit 1 here. And in the unit 1 what we had cover up is the introduction, concepts and scope of industrial management, productivity, definitions, measurement, productivity index, the types of production system, and industrial ownership. In unit 2 what we had covered up is here the functions of management, tailors the scientific management theory, FIAL's principles of management, social responsibility of the management, introduction to human resource management, nature of HRM, functions of importance of HRM. Then in unit 3 what we had discussed about the work study, introduction, definition, objectives, steps in the work study, method study, definition, objectives, steps of method study, work measurement, purposes, types of study, stopwatch methods, step allowances, standard time calculations, work sampling, production planning and control, and inventory control, that is inventory cost, models of inventory control, EOQ, ABC, VET here. In the unit 4 what we had covered up is the quality control, statistical quality control, control charts for the variables and attribute, acceptance sampling, single sampling, double sampling plans, introduction to TQM. Now we'll have end up with a fifth unit, and that is the project management, project network analysis, CPM, PERT and project crashing, and of course the resource leveling, that what we had covered up in these classes. First of all, it's a huge request to all the subscribers, please go through with the subscribe button so that you will get all the information regarding it, what we are offering here. And we'll uploading the videos related to the industrial management, we had uploaded that, and we'll had end up with that as well, and we had completed the cyber security as well. Now we'll start with the web technology and the reasoning classes which we are going to continue from today itself, and you will gone through with that as well. And where we had cover up the reasoning, verbal reasoning we had cover up, and in non-verbal reasoning we have to start with. So first of all, it's a huge request to all the subscriber, please go through with the subscribe button and like, share and subscribe our channel here. Thank you, thanks for subscribing us, thanks here.